Welcome back from the ad break, and let's continue with our lesson. Remember, we were multiplying two binomials. So let's continue with that. Let's look at a number 3 here. So we're going to simplify the following expressions. We are going to multiply the first ones. Remember the method that we used to multiply? We are going to multiply the first one, so that is f multiplied by f, and that gives us f squared. Then we're going to multiply the outer one, so that is f multiplied by 4. But remember now, because we are subtracting in the second bracket, then we are just going to put down a subtraction there. So that is f multiplied by 4, that is 4f. Then we are adding here, and then we are going to say 4 multiplied by f, that is 4f. And then we are subtracting, so that is 4 multiplied by 4, and that is 16. Now we need to simplify this further, and that is by looking for the like terms. The like terms, if there are any, we need to add or subtract them. So if we look at the like terms there, we do have 4f, a negative 4f, and a positive 4f. Now remember, they are like terms because they have the same variable, and the exponent for that variable is 1. So now we have f squared. Then we have a negative 4f plus a 4f, and that gives us a 0f. So with the variable of f, we no longer have anything there. And then we are just left there with a minus 16. So that is our answer for that binomial, for that product of the two binomials. Let's go on to the next example. So now this one here, we have 1 multiplied by 2. Remember, we are starting with the first ones. And 1 multiplied by 2 is 2. Then we are subtracting. We are going to now multiply the 1 with the 5t exponent 9. That is going to give us 5t exponent 9. Then we are going to multiply. We are subtracting. We are going to multiply t exponent 4 multiplied by 2. That is 2t exponent 4. And then we are subtracting, and then because now we are subtracting in both brackets, then that means, remember, when we subtract a negative number, that becomes a positive. So we are going to say now that will become a positive, and then that is t multiplied by 5t exponent 9. It is going to be a 5. The t exponent 4 and the t exponent 9 have the same base, so because we are multiplying, we are going to add those exponents. So 9 plus 4 is 13. So that 13 is the exponent for the t. Let's go on to the next one. So we have here two binomials, and we are going to multiply using that method of making sure that each one multiplies with each term in each binomial. So we are going to say now 9 multiplied by 2, that is 18. And because there's no variable with the 2 there, we're just going to write this variable as it is there with the 9. Then we are going to say 9 multiplied, so 9m exponent 5 multiplied by m exponent 4. That is going to be, now because we are adding, my 9, and then same base, we add those exponents. Then we continue with our adding. That is going to be 1 multiplied by 2. That is going to be a 2, and then we are going to continue and say 1 multiplied by m exponent 4. That is going to be m exponent 4. We look for the like terms. There are none. And then, remember, we just make sure that we put our algebraic expression in descending order of exponents for the variable. So in this case, we are going to say it's 9m exponent 9 plus 18m exponent 5 plus m exponent 4 plus the 2. Our next one there, again, two binomials. Let's multiply. 10 multiplied by 9, that is 90. And because the 9 doesn't have any variables, we are going to keep those variables as they are. Then we have 10k squared multiplied by k exponent 7. We are adding there. That is going to be 10k. We add the exponents. That is exponent 9. Then we are subtracting. We have 12 multiplied by 9. Now 12 multiplied by 9 is 108. Then again, we are subtracting. We have 12 multiplied by k exponent 7. That is going to be 12k exponent 7. Again, we look if there are any like terms. If there are no like terms, we just make sure that we put our algebraic expression in descending order of powers when we are looking at the exponents of the variable, right? So that our final answer is going to be 10k exponent 9 minus 12k exponent 7 plus 90k squared minus 108. So the last part of our lesson is the squaring of binomials. Now it's not too different because we've been now multiplying two binomials. So when we talk about squaring binomials, let's see how we can calculate those or determine those. When we square a binomial, we need to write out the binomial twice, since squaring any polynomial means that the polynomial is multiplied by itself once. So we know when we are squaring anything, we multiply that number or polynomial by itself once. So the same case will be for binomials. For example, here we have x plus 3 squared. So what is supposed to happen here? We are going to simply write out this binomial twice. So x plus 3 multiplied by x plus 3. Can you see how now it looks like the other binomials that we've been multiplying? So we are just going to multiply here. That is going to be x multiplied by x, that is x squared. Then x multiplied by 3, that is going to be 3x. We are adding, then that's 3 multiplied by x, that is 3x. And then that is 3 multiplied by 3, that is 9. We are going to look for the like terms there, and we can see that the like terms are the 3x and the 3x. And the reason for this is that they have the same variable, and that variable has the same exponent as well. So what is 3x plus 3x? That is 6x. And we are left with x squared plus 6x plus 9 as our answer. Let's look at the next one. The next one there we have 3a plus m squared. So same thing is going to happen. We are going to start by writing out this expression or this binomial twice. So that is 3a plus m multiplied by 3a plus m. So let's multiply. What is 3a multiplied by 3a? That is 9a squared. Then we have 3a multiplied by m. That is going to be our 3am. Then we have m multiplied by 3a. That is also going to be 3am. And then what is m multiplied by m? That is going to be our m squared. Again, we are going to look for the like terms there, and I can see two of them because they have the same variables, and those variables have the same amount of exponents. So what is 3am plus 3am? That gives us 6am. So our final answer is going to be 9a squared plus 6am plus m squared. Let's look at two last examples before we can end our lesson. We have number 3 here, 3 plus k, and that is squared. Again, we are going to write out this expression 2 times. So that is 3 plus k multiplied by 3 plus k. Let's multiply. 3 multiplied by 3, that is a 9. We are adding 3 multiplied by k, that is 3k. Then we have 3 multiplied by k, again that is 3k. Then we are still adding, we have k multiplied by k, and that is going to be your k squared. We look for the like terms, we have 3k and 3k. So that is going to be k squared, because we are writing them in descending order of powers, that is k squared plus, what is 6k? What is 3k plus 3k? That is going to be 6k, and then we end off with that 9. And that is our answer for that squaring of that binomial. The last one here is going to be p minus 6. Again, we are going to write out this expression twice, p minus 6, p minus 6. Let us multiply. So what is p multiplied by p? That is going to be our p squared. We are subtracting, then we're going to say p multiplied by 6. That is going to be our 6p. Again, we are subtracting, then what is our 6 multiplied by our p? That is going to be our 6p. And again, we are subtracting, but because we're subtracting in both brackets, subtracting a negative gives us a positive. So that is going to be now 6 multiplied by 6, and that is going to be our 36. There are like terms here. That is the 6p and the 6p. So our final answer is going to be p squared. What is a minus 6 minus 6? That is going to be a minus 12p. And then we are left with plus 36. So my final answer will be p squared minus 12p plus 36. That was an interesting, fun lesson. I hope you enjoyed it as much as I did. We hope to see you next time. Goodbye.